Now let's solve question number 30 from exercise 2 of laws of motion chapter from phase 1 book. Let's see it. A person with his hands in his pocket is skating on ice. The rate of 10 meter per second, speed is 10 meter per second, and describes a circle of radius 15. What is his inclination to the vertical? Okay. Now, first of all, let's focus on this. Skating on ice. The skating is very different than the walking. When you're using the skates, it's not same as walking, because when we are walking, we cannot dig a hole in the floor. But when you're skating, the skates will go in the ice. So if this was the ice earlier, in case of skating, skates will go inside. Since the skate will go inside, they will be able to shift the direction of normal reaction because they're inside. The actual contact will be happening like this. They'll be changing the surface area, dimension of surface area. So while walking, you cannot shift the direction of normal reaction because you cannot dig a hole. But while skating, you can do that. Especially on the ice, you can do that. Because ice will be making a hole. So that's something special in this question. It's all about this. So now let's see if I make the FBD of that man who's skating, performing the circular motion, the normal reaction is shifted. mg is still acting downward. Let's say from the vertical, angle made is theta. So the new two component of normal reaction, one will be in cos theta and one will be in sin theta. And this skater is performing the circular motion towards the center, which is in this direction. The centripetal force is required, and that centripetal force will ensure the centripetal acceleration is c. So let's, along the vertical, the acceleration is still 0. If I balance along the vertical, I'm getting cos theta as mg. That gives the normal reaction as mg by cos theta. Now along the horizontal, n sin theta is the force, which will provide the required centripetal acceleration, meaning net force along the horizontal, which is n sin theta, will be equals to m times of EC, which is nothing but v square by r. Now let me replace the value of n from here. So I'm going to get mg sin theta divided by cos theta. That will give us tan theta. That is equals to v square by r. MCF cancel. So tan theta is coming out as v square upon g. If I replace the value of v square, which is 10 into 10, radius, which is 50, and the g, which is 10, I'm getting 1 by 5. So tan theta is coming out to be 1 by 5. So theta is tan inverse 1 by 5. That's the right answer. In this case, in this question, we have learned something special, and that is what happened in case of skating on ice. How the normal reaction is shifting, which will not be happening in case of walking and running. So, unless you are wearing the spikes. In case of spikes, the same thing can be achieved because spikes will be going inside this floor. So if you check the option B is saying tan inverse 1 by 5, so that is going to be the right answer. Okay. Thank you.